All right, so we are in AP Calculus. Today's date is Wednesday, October 23rd. We are missing Claire today. Today we are talking about tangent line equations. We see that we are on a brand new unit, Unit 4. Here's our Unit 4 guide. We have 9 lessons, then self-check, pre-test, fix-up, test. Everything is updated on the website, so this stuff is all up. We have a giant packet printed out for all of the notes, all of the homework. So if you're absent now, you have all of that. Sorry, Claire, that you're not here to get that packet. What is our objective for today?
Use your tangent line to approximate values.
There it is. So this is a very fundamental rule, even when you study higher level math in college, is, oh man, I have like this weird curvy thing happening. Well, let's just make a line and then we're going to be off with really far values. But if I just approximate it with a line and use really close values, then it'll be an okay approximation. So point-slope form is something from Algebra 1 that you should have memorized, and I think we just did this in pre-calculus too for review, so you should really have it down. All right, so if we have a point at 3, 2, and we know that the slope is 5, we need to write in the equation the line. So in terms of analyzing what's happening in the words and translating it into math, in terms of a coordinate pair, it goes, is it yx or xy? xy. And then slope. What is another way that we can write slope in notation?
Just
M is the letter that we use from Algebra 1, but in calculus we use a different thing for slope. It is indeed f prime. So we say that f prime of 3, because you take the x coordinate, is 5. Or if you would like to even write it faster, just say f prime is equal to 5. But technically it should be f prime of 3 is equal to 5. All right, so you should know your equation. Anyone want to take a guess at it from pre-calculus? You should know this. Go for it, Stego.
y2 minus y.
Oh, you're doing the general formula?
Oh.
That works too. So generally you have y minus y1 equals.
Isn't it y1 minus y2 or x?
You're doing slope.
No.
Oh.
It was,
M, and then instead of M we have
prime?
f prime. Yep, f prime times
X minus x1.
x minus x1. And a lot of the times I can write this another way as y minus box is equal to box times the quantity of x minus box. And that lets you know that, hey, those are the things that you need to find. So either way works. So knowing that that is the general equation of a line, of a point-slope form line, how do we write this information up here using our formula down here for point-slope form?
So it's going to be y minus 2 equals 5 parentheses x minus 3.
There it is, x minus 3. Thank you, Gio. All right, so we have point-slope form down. You're going to be using that over and over again. You'll be surprised how much you use this over and over again. Whenever you see a question, it's usually a multiple choice question that asks you, what is the equation? Not what is the slope, but what is the equation of something? You are almost always going to be using point-slope form. All right, so estimating with the equation of a tangent line. So let's go ahead and start labeling this diagram. Let's go ahead and say that this point occurs at x is equal to 1. So this is 1 down here. Let's say that the height over here is 2. I guess it's not drawn to scale. And let's go ahead and say that our slope here, f prime, is equal to 3. So first we need to build our function, and then we can use it to estimate. So let's build our function first.
So y minus 2
Y minus 2
equals to 3 x minus 1.
x minus 1, perfect. So we can now use this line. So say we have some general curve here that I did in blue.
I have a question.
Yes.
So when this, is there going to be like a graph where the height is going to be negative?
Yes.
And that it's going to turn into positive? Negative?
Yep, exactly. You'll have a double negative if one of these x or y's is a negative. Maybe I should have done that for an example. So let's say I want to approximate something like over here. Let's say I want to approximate this value right here, and I'll say that's at 2. How would I do that? How would I approximate this height right here? What height would that be at 2? Well, we don't know this blue function, but we know the tangent line. So let's plug into the tangent line, and we'll get this value, which is really, really close to the height of the actual curve. I'll say that one more time because that's the general idea of this entire lesson. So I want to figure out what the height is for this point. The whole thing is, what is this? The question. And I know this occurs at x equals 2. What I can do is I can plug into this equation, which will give me a height that's on this line, which is really, really close to the height of the actual curve. Obviously, if we choose a point that's farther out, then we're going to have much more error. But if I choose a point that's pretty close, then I shouldn't have too much of an error. All right, so how do I do that?
You solve for the first equation.
You plug it in the 2 for x.
Yeah, I just plug in this 2, and I plug that into x, and I will pop out a y. That'll be the height on this line. So if I plug in that 2, then I have the equation now. I'll write everything in blue again except for the thing that I'm plugging in. Y minus 2 is equal to 3 times the quantity of, and it's going to be 2, because I'm plugging in 2 for x, minus 1. And then you can do some mental math. So I'm going to do 2 minus 1, shout it out, is, and then that 1 times 3 is,
Yeah,
1 times 3 is
wait,
3. And then I need to add 2 to both sides, so 3 plus 2 is 5. So we say that that height is approximately, we'll do this little wavy sign, approximately equal to 5. All right, so let's go ahead and see an example. This is a very, very similar example that you might see on an AP test. And sometimes they do it on a free response as well, where they say, now that you've done a bunch of math, now actually use that math. So let's say we did a bunch of math and somehow we found a function that was 5x squared. We need to first find the equation of the line tangent at this x coordinate, and then we'll have to approximate 1.1, which again is really close to the x coordinate that we were talking about. So it will be a really close approximation. The key giveaway here, can we all underline the word equation? Whenever you see the word equation, that means you're using this formula up here, the point slope formula. All right, so help me set it up. Every single time you see equation, write the general form and use boxes because you'll be filling in those boxes. So, Sego, tell me the general form for point slope form.
Y minus box equals x.
There it is. So you're going to be doing this over and over on the homework too. I'll move this up so we can give ourselves some room. All right, so what do we know? What can we fill? We're trying to fill in these boxes first. And then after we fill in those boxes, then we can plug in 1.1. So what do we know from this already?
X is 1.
X is 1. So let's come over here and say, okay, this x is 1. What else do we know?
The slope is 1.
That's not the slope. This is the function. We're going to plug this 1.1 into x after we find these two missing values. But first we need to fill in all the boxes before we plug in 1.1. So we can figure out y pretty quickly. If I plug in x equal to 1 into our equation, then that will pop out a y. That will give us a y. So let's do that really quickly. We can say that over here on the side notes, we can say that y is equal to 5, and then in the place of x, I'm plugging in 1 squared. Again, I'm plugging into this equation. Instead of saying f of x, I'm just saying y, because this is the same thing as saying y. So I'll just leave that up above. So 1 squared, mental math, go.
1.
1 times 5?
5.
All right, so this is 5. So let's come back over here and say our y coordinate is 5 because we plugged in our x equals to 1 into our equation. All right, how am I going to find slope? F prime, there it is. I'm going to find the slope by taking the derivative. So let's go ahead and do that. Oops, I don't want to grab all that, just the arrow. So here we go. F prime is equal to what? F prime of x, go for it, is equal to,
10x.
yep, the 2 comes down, 2 times 5 is 10.
Take the F from that.
Yeah, taking the derivative, so I have 10x to the power of
One.
1. Yeah, so just 10x. All right, and then what is the x coordinate that I'm talking about?
The 1.
1, yeah, so we're saying f prime of 1 is equal to 10 times 1, which is just equal to 10. So we know that the slope here is 10. So our first step is filling in all the boxes for this point slope form, and then from there, now I can plug in x is equal to 1.1 and figure out what the height is. Are there any questions up to this point? All right, so let's go ahead and do it. I'm going to rewrite our equation down here. We have y minus 5 is equal to 10 times the quantity of something minus 1. That something, the x that I'm plugging into, is 1.1. So I'm going to say 1.1. All right, and then some more mental math. What is 1.1 minus 1? 0.1.
Is it really 1 again?
Yep, and then 10 times 0.1 is just 1, and then 1 plus 5 is?
6.
So y is equal to 6. So the value of f of 1.1 is about 6. So we can say down here, f of 1.1 is approximately, because we had to approximate using a line, is approximately 6. Final answer, box it. All right, make sure that you understand everything. I'll give you about 20 seconds to digest, go through the whole process again. How did you get from this step to this step? That would be a good question to ask. Why did you write this? Why didn't you write this?
Seems pretty clear.
Well, you did it once before, so I'm hoping so good. Geostego?
It's
Good,
I'm just
good.
writing notes for myself.
All right, cool. That concludes the notes.